again, I want to just remind you, try to learn it for yourself. Many companies love this finite element methods. Many opportunities are there. If you are good at this, you can find good positions. I hear this all the time. So learn it for yourself. The program is very user-friendly. Just enjoy the program. Do not just try to just finish this commands that I put on the handout, but which are very, of course, it's a good coverage of this, but explore it more yourself. All right, with this now, let's see a couple of words. First of all, remind you about the quiz which we have on Monday next week. You go to Canvas, you don't need to come to Zoom, just directly go to Canvas, click on quiz, and the quiz one is there. Solve the problem. Again, scan it, upload your PDF file on Canvas. So that's what the format is. It covers everything, whatever covers chapters 1, 2, and I think 3, everything that we covered. Solve the homework problems which are listed on the syllabus, and also the handout, the notes. Usually students say they're very helpful, very clear. So follow the notes. The textbook is very clear. So prepare chapters 1, 2, and 3, I think. Solve problems. Canvas will not accept late submittals, as you know. So you start sharp at 10 o'clock. You don't need to come to Zoom. Directly go to Canvas, take the test, and then submit according to the whatever time, 30 minutes, 40 minutes, 50 minutes. I don't know. I have not made the test yet, but it tells you how long the test is. Those who are the DRC students, send me a message that you take 1.5 times, or the time is 1.5 or twice the time. So again, you start at 10 o'clock and submit at the time which is Canvas tells you to do. All right, I think with this, write clearly and box your answer always as usual. And now let's go to see what our plan is for today. Let's go to modules. Let's quickly look at the syllabus. The syllabus always, you know where we are and what we are going to do. Scroll down this last page. It is the course schedule. We are here September 15th. So activity number 4, analysis of a beam problem. Last week we did a truss problem. Trusses are very simple structures. Beams are more advanced. We did the finite element formulations for truss problems. So we know the theory and we know the practice. So combination of this is very good. Now let's go for beams. We are going to solve problem 421 of our textbook. So let's go back to modules. This is here, September 15th, activity 4, click on this beam. That is what you are going to do. Solving a beam problem using NX-Nastran. This is problem, 421 of our textbook. This is this beam. This is an overhanging beam subjected to this uniformly distributed load. It is fixed at this point on a roller here. So it just applies a force upward, no horizontal or no moment resistance. It's just a force upward. And the modulus of elasticity and area moment of inertia, they are given. Again, like what you did last week, create the nodes, you go to define the material, the modulus of elasticity, you go to define the model property, that would be you define the cross-sectional area. This is a rectangular cross-sectional area. For beam problems, of course, we select the type of in Nastran beams are used to model beam and frame problems. So you select beams in the model property. This is a rectangular cross section. You specify the dimensions of this, and then you define the element and also you define the constraints, you define the loads. This is a uniformly distributed load, again, as what you did here, and then solve, you go through these steps to define what type of analysis you want and plot the results. It describes how to do this again, get nodal displacements, get forces and moments, and it shows you what selections to make to get the forces and stresses, for example, at end A or end B. End A or end B, it is here, beam element terminology. In FEMAP, a beam is like this. It shows one element. So this is end A, end B, and this is the terminology. It tells you what beam end A is, beam end B is, and plane 1, plane 2. And combined stress here, pay attention that combined stress, sum of axial shear and bending stress. No, torque is not included. So the way that FEMAP defines equivalent stress or combined stress is that not including the torsion shear stress due to torque, but it includes the effect of axial and transverse shear and bending stress, but it doesn't include torque. So this is the definition that FEMAP uses. Usually by equivalent stress or von Mises stress, we mean all of them combined. But in FEMAP, this is their definition. So torque is not included. Show the stress contour, get the reaction forces. It tells you what to do. So these are all descriptions to how you can get these items. But what I need from you in the report, material to hand in for a grade. This is what I need from you in your report. Plot a graph of deformed and undeformed shape. This is always very important to superimpose both of them together so we can see when the structure was before loading and after loading. So we see that if this deformation makes sense or not. So get this, this would be one graph of deformed and undeformed shape. In also a table showing nodal displacements, maximum and minimum stress, and reaction forces. This is one table. You know how to get this. Descriptions are also here. Is overall equilibrium achieved? This is very important always to make sure that our solutions are correct, not garbage in, garbage out. You give some numbers, also FEMAP and NASRAN return some nonsense results. So, but with nice, colorful pictures, but they are meaningless. So we don't want that. We want correct answers. So make sure that always you verify and you validate your solution. One way in solid mechanics is by doing this equilibrium. So use one of the graphs that you get from FEMAP, write the equilibrium equation, sum of forces in the x direction to be 0, sum of forces in the y direction to be 0, and sum of moment about any point select on the structure to be 0. So make sure equilibrium is, show all the data, write the formula, and then plug the numbers. Solve the problem again. But this time use 16 equal length elements. You see previously in your first run, this one, you have node 1, node 2, node 3. So we have 2 elements that you run it and you get these graphs and tables and results. Then you go back and run it again with 16 equal length elements. Compared to the first run, we want to see if increasing the number of elements, in other words, reducing the element size changes, what changes it makes. What is the percentage change in the maximum displacement? So you get the maximum displacement, compare them. Maximum stress, minimum stress between the two runs. So you create a table here, run 1, run 2, and all these items, maximum displacement, stress, maximum stress, minimum stress, run 1, run 2, what you get, and the percentage change. Provide the above graphs tables for both runs. So for both runs, you provide this information. So it means for first run, you get one graph here, one table here, show the equilibrium is satisfied. And then you run it for this case. And then again, this show a deformed and undeformed shape and nodal displacements, this table. And so provide the information for both runs. Show all calculations used to answer your questions. Type your work. Type your work. No handwriting. Do not anything handwriting. In finite element analysis, we do analysis of a problem and then we send the results to other departments, sometimes to other countries. Sometimes you do analysis next year. This part that you have done, the analysis comes back to you, and then your boss asks you, now this part was broken. We make this, we put it on the machine, then this part broke, and customers are complaining about this piece. So do the analysis, see what is going on. So you are ready to do the analysis again, see what, if you have done any mistakes or not. So you have to have this report always so you know what you have done before. So make sure that you type everything professional. Although it is memo format, doesn't mean that it is, but it is good enough amount of information that you know what you have done, so you can modify or make changes to the design of that part. That is all I wanted to say. Usually these lab activities, these assignments are you can do during the lab period, but it is due at the beginning of next week's lab, like what you did this week. So, but you can finish it at the end of the lab, if in case that you cannot finish this. So, but the report is due at the beginning of next week's lab. I do not take usually a long time, just 10-15 minutes maximum I discuss, because I want you to have time. This is activity. I want you to be active in your work. All right, that's all I wanted to discuss. Any questions about the activity or about the quiz or anything?
For number 1, did you prefer it to be in one photo or in separate photos?
This one?
Right.
Print one graph. One
Okay.
graph show deformed and undeformed. One graph show deformed and undeformed.
I think for the third activity, a lot of us got a little confused and put it into 2 separate photos. So I just wanted to double check.
Yeah, no, that's what I said it, and I say it again, always, almost always, maybe if it is, I will say in a separate graph, but here I'm saying a plot of the deformed and undeformed shape. So I need one graph, both of them superimposed. All right.
Professor, I had a question.
Yes.
So just to confirm, it seems like we're going to have more plots and tables this time than we did for the last activity. Would you prefer having one plot or one table per page just for ease of reading, or would you like us to combine them into multiple pages, or does it not matter to you?
No, I don't want one page, one table per page. No, just go through 2 pages. You can fix this, and then just embed your table in between your discussion. So that is fine. There is no need one table per page.
Okay.
As far as it is easy to read and follow, I want something quick. People nowadays, everybody is in a rush. So you want to look at this quickly, see in this table, I want this table quickly to see what is the, for example, how do you compare this run 1, run 2, maximum stress, maximum displacement. So give a table here like this for this one and embed the next one also here, but label this, always label your tables or figures under this, write a caption what this figure or table is. So it is easy to understand what you have done.
Okay, thank you.
All right, sure. Any other questions?
Yeah, just to clarify, the calculations that we need to show are referring to like calculating the percentage change, right? Because we don't need to show the calculations used in Nastran, right?
No, you don't do calculation in Nastran, but this equilibrium I want you to show. This equilibrium, write the equation and plug the numbers, show the data that you get. Also for this percentage change, yes, show that you use this formula. Just for one case, show that this percentage change was found. Like
Okay.
Show all calculation. Yes, show this calculation. Yeah, this equilibrium is important. Make sure that you have done it correctly. Otherwise, then there is something wrong with the reaction forces. Get the reaction forces here, free body diagram, make sure equilibrium is satisfied, but show it so we know what forces and moments were external or reaction forces. Show your work always. All right, any other questions?
Professor, I had a question regarding the submission because my computer was failing when I was trying to do it and I couldn't do it in time.
You have to, you have 5 minutes always to do this. This is the same policy for everyone. Let's make this very the same policy for everyone. I have repeatedly said it will not accept late submittals. So 5 minutes was enough to be able to do this. All right, any other questions? Anything else?
Yeah, I don't really think it's fair to not allow him to submit if it's just a computer problem.
So what should we do?
Allow him to submit.
So we don't have any time limit for submittal?
I think we should allow him to submit this time, but I think if we can make the submission link up earlier, maybe throughout the week, starting now and then ending maybe like 10:05 the next week. You know, instead of just giving everyone a 5-minute time period, just start it now and then end it 10:05 next week.
Well, the reason I do this is because I do this, I randomly collect, that's what I randomly collect activities. So those that I do not collect, so there is no need to submit, but I collect when I grade them. Let's do this. I will make it possible. 10 minutes is good enough?
Yeah, I definitely think 5 minutes is too short because I've had my computer crash during class and stuff. Never during assignment like turn-ins, but I've had computer issues, and that seems a little bit short and for your computer to reboot.
It took me almost 4 minutes to submit.
How about 10 minutes? Good enough?
Yeah, 10 sounds really good.
Yeah.
Okay, I will change it to 10 minutes. And your friend that this time you said this, send this by email to me.
I already sent it through email when I got my computer to work again. It was like right after submission.
Andres, could you speak louder? I cannot. I don't.
Oh, I said that I already sent it to email. Like it was like I fixed my computer like almost right after the submission ended.
Okay, all right, that's fine. From now on, I make it 10 minutes. So, but you should have it ready before. So at the beginning, I tell you, and you're ready to upload this. But I will change the time to 10 minutes. All right, any other questions? All right, everyone, I stop here. Next week, again, for the quiz, go directly to Canvas. There is no need to come to Zoom. Go to Canvas and take the quiz. Make sure that your computer works, because you see everything is just, it's online. So what can we do? There should be a policy for everyone. Make sure that your computer works, and then you submit your work on time on Canvas. All right, with this, I stop here. Everyone, have a good rest of the day. I will see all of you on Wednesday next week for the lab. Take care, everyone.
That's-
Thanks.
All right, sure.
Do we have to show up for Zoom afterward?
No.
Okay, thank you.